Today we are going to check out how to use the logarithm table to find the log values and the anti-log values. Now let us take an example. How to find the log value of 53,351. For this, we have to take the logarithm table. While checking the logarithm table, we have to choose the rows and columns based on this number 53351. The first two numbers are the basis on which we choose the row, that is 53. We have to look into the row corresponding to 53. Then the next digit is 3. So we have to consider the column based on that digit, that is column corresponding to 3. Then the next digit is 5. We have to consider the mean difference based on the fourth digit, that is 5. So when looking into 53rd row, third column, we get a value. And with this value, we have to add the mean difference corresponding to the column of 5. That is the value required. That is, we get a value from the 53rd row and third column. With that value, we have to add the value in the fifth column of mean difference. Then we get the log of 53,351. Now, this is the logarithm table. These are the column headings. Here comes the row headings, and these columns form the mean difference. Now we have to take the number 53351, and in this number the first two digits represent the row. So we have to find that 53 in these row headings. Then the third digit 3 is this one, 3, that is the column heading. And then the next digit is 5. And we have to look into the mean difference column for that 5. See, here this 5. So let us check for the 53 in this row. So we have to go down and more down, and here is the 53. 53 in the third column. This is 0, 1, 2, 3. So 7267 is the required number. Now, based on the fourth number or the fourth digit in this number, we have to add the respective mean difference value. So we have to move to the mean difference column in the same row, and the fifth one we have to select because the digit is 5. So it will be 1, 2, 3, 4, 5. Now this is the fifth column. Thus we have to add this 4 with this 7267, and thus we get 7267 plus 4, that is 7271. Thus, the log value of 53,351 as per the table is 7271. But we write it as 4.7271. Why do we include this 4 and the decimal point here? This has to be discussed in detail. Our number is 53,351, and we are finding the log of that value. Now let us check out how many digits are there before the decimal point. Here the decimal point will be after 1. It will be just like 53,351.0. So how many digits are there before the decimal point? 1, 2, 3, 4 and 5. 5 digits are there before the decimal point. So we subtract 1 from this 5. 5 digits are there. So we put 4.7271. Thus, this 4 represents number of digits to the left side of the decimal point minus 1. When there are 5 digits to the left side of the decimal, we write it as 4. Now let us take another example. When it is log 5335.1, then let us check out how many digits are there to the left side of the decimal point. 1, 2, 3, 4. So 4 digits are there and we subtract 1. That means when there are 4 digits and we subtract 1, we have to put it as 3 point and it becomes 3.7271. Let us check out another value. When it is log 533.51, then there are 1, 2, 3. 3 digits before the decimal point. Thus, we put it as 2.7271. And if it is 53.351, then there are 2 digits to the left side of the decimal points. Hence, we put it as 1.7271. And for 5.3351, only one digit is there before the decimal point. Hence, we minus 1, we get it as 0. So, it will be 0.7271. Now, if it is log of 0.5331, that means to the left of the decimal point, the value is 0. Hence, we put it as 1 bar. Bar 1.7271. And to the right of the decimal point, if there is one more 0, just like 0.053351, then here to the left of decimal point there is 0 and to the right also there is 1 0. Thus, we put it as 2 bar. And again, if there are 2 zeros to the right side of the decimal point, then we put it as 3 bar. In this manner, we can write as many decimal point values according to the question. Again, if there are more zeros, just like 0.000533351, here in this case, we put it as 4 bar. And the 7271 will remain the same. Thus, the decimal point and the 0 values are the basis on which we put 4 point, 3 point, 2 point, 1 point, 0 point, etc. while finding the logarithm values. So here our number is 53,351. Let us check out how many values are there before the decimal point. 1, 2, 3, 4, 5. So subtract 1, then we'll get 4.7271. Next, let us study how to find the anti-logarithm values from the anti-logarithm table. Let us take an example. Here we are going to find the anti-log value of 2.4645. The rows and columns for finding the anti-log values is based on these numbers. For the time being, we are ignoring this 2 because that is used to decide the position of the decimal point. So, these 4 numbers 4, 6, 4, 5 are used to determine the rows and columns for finding the anti-log values from the anti-logarithm table. First of all, let us take the first two numbers, that is 0.46. So we are going to select the row corresponding to the value 0.46. Then let us move to the next digit, that is 4. So we are going to select the column corresponding to the value of 4. Thus, in the row of 0.46 and column corresponding to 4, we get an anti-log value. And to this value, we are going to add the mean difference. So, this last digit 5 is used to determine the column of the mean difference. So, we add the value corresponding to the mean difference of 5 to the previously obtained number of the 0.46 row in the 4 column. Thus, we get the anti-log value from the anti-logarithm table. To this, we put the decimal point based on this number 2. Now, let us check out how it is actually done. This is the anti-logarithm table. These are the column headings and the row headings. These are the column headings of mean differences. Now our number is 2.4645. So ignoring the 2, we have to consider the 0.4645. That 0.46 represents the row heading. So we have to go up to 0.46, go down, and here comes the 0.46. This 0.46, then next digit is 4. So it is in the column heading 4. So 0.46, this is 0, 1, 2, 3, 4. That means our required number is 2911. Now the next digit is 5. 0.4645. So the last digit is 5. Thus, we have to move into the mean difference table to get the last digit. So, 1, 2, 3, 4, 5. The fifth column, the number is 3. Thus, we have to add 2911 plus 3. Thus, we get 2914. So, the antilog of 2.4645 according to the antilog table is 2914. Now, we have to decide where to put the decimal point. Here, it is just the opposite of what we have done for the logarithm values. Here, the number is 2.4645. And the value we got is 2914. Now, when it is 2.4645, then we have to put decimal point after 3 digits. 2 point means after 3 digits we put the decimal point. Suppose it is antilog of 1.4645, then we put decimal after 2 digits. Then it becomes 29.14. Suppose it was 0.4645, then we put decimal after 1 digit. Here it is 0 point, so plus 1. That means we put decimal after 1 digit. It becomes 2.914. Suppose it was 1 bar point 4645, then we put the decimal before the first value. It becomes 0.2914. Suppose it was antilog of 2 bar point 4645. Then we put like this 0.02914. And if it was 3 bar, then we put it as 0.002914. That is how we convert the anti-log table value. It is done just the opposite of what we have done in the case of the logarithm values. Thus, antilog of 2.4645, we have to consider the 2 point. When it is 2, we have to put decimal point after 3 digits and it will be 291.4. So this is how we look into the logarithm table and the anti-logarithm table. Thank you for watching this video. For more videos, you can subscribe the channel.